Hi guys, today we're going to work on IXL assignment TZ6, write fractions in lowest terms. So when we're talking about writing fractions in lowest terms, you'll also hear myself and others refer to this as simplifying fractions or also reducing fractions. Those are all different ways of saying it, but if we think about it, lowest terms, means it's getting smaller. Simplifying, if you make something simple, you simplifying it, you're making it as small as possible or as basic as possible. If something's being reduced, once again, you're making it smaller. So all of these is us writing, or all of these are other words and other ways of saying we want to write fractions in lowest terms. We're going to simplify them. We're going to reduce them. There are two primary ways that you can go about simplifying and reducing fractions. And I honestly use both methods. It just kind of depends on what the numbers are and what my familiarity is with them, on which ones I use. So method number one is simply using the GCF, otherwise known as greatest common factor. So if you're simplifying something by finding the greatest common factor, we look at this fraction that we're given here, 12/16. So you would list all of the factors of both 12 and 16 and find the GCF of them. So we can see her on the left in blue, or sorry, on the right in blue, we've listed all of our factors of 12, and then we've listed in red all of the factors of 16. And the greatest factor they have in common is 4. That means we can simplify, we can reduce our fraction by that GCF of 4. That's the greatest number they are both divisible by. So when we take the numerator 12 and divide it by 4, we get 3. The denominator 16 divided by 4, we get 4. And we can feel confident that that is the lowest version of the form. So that's one of the pros, that's one of the perks of using GCF, is if you really do find the greatest common factor, you can know for a fact that you only have to divide one time, and that will give you the lowest form of that fraction. The other method that you can use is simply just repeated division. So this is one that I do use. It's just with this, you have to be confident and you have to say, okay, how many times do I need to keep dividing this by a common factor until it is fully simplified and in lowest terms? So in this case, if we look at the fraction 24/16, you can say, okay, what is a common factor? What's something I can divide them both by? And maybe 4 is the first number that pops into your head. Great. Divide by 4. So 24 divided by 4 is 6. 16 divided by 4 is 4. So that gives us the fraction 6/4. That's reduced a little bit, but it's not in lowest terms because there's still another common factor. Well, 6 and 4 are both even numbers. So I can divide by 2, and that gives us 3/2. And now I know that I am done, because if we think about our factors of 3, the only numbers that can multiply together to equal 3 are 1 and 3. Our factors of 2 are 1 and 2. Well, the only thing they have in common is to divide it by 1, and it doesn't change its value any, so we're done. So this honestly is a nice method because it can, maybe be a little bit quicker for you because you're not having to list all of the factors out of 24 and 16. Just the thing that you have to be careful of is that you continue to divide and know when you really are, in fact, done and you have it in the lowest form. All right, so we're going to head on over to IXL. I'll make sure to use a mixture of these two methods so you can see examples step by step of both. And, maybe you'll find that there's one that you use 100% of the time, or maybe you'll be like me and you kind of use both. It just depends on whether the numbers are smaller or bigger as we go throughout. All right, here we are on IXL. Remember, we're working on assignment TZ6, write fractions in lowest terms. So we are being told here to write 2/4 in lowest terms. And you can see IXL has set it up pretty nicely for us where we just have an answer box for the numerator and the denominator. So this is one where I would just honestly use repeated division because I look at this, the numbers are really small, and I say 2 and 4 are both even numbers. I know that I can divide that by 2. And remember, whenever you're dealing with simplifying fractions, you have to simplify both the numerator and denominator because we have to ensure that the entire fraction remains equivalent. So 2 divided by 2 is 1, 4 divided by 2 is 2, and then when I look at the numbers I'm left, 1/2, I just know that that's simplified because I've, had a lot of practice with it, but, to help you get to that point too, where you can be the same as I am with this, is if you look at that numerator, it's just a 1. 1 times 1 is the only factors of 1. And then when we look at 2, 1 and 2 are the only factors of 2. So there's nothing else aside from 1 that we can divide it by. So when we type this into IXL, we just put the 1 in the numerator, the 2 in the denominator, and it will be marked as correct. All right, now we want to do 6/10. So this is one where I'd probably use the repeated division again, just because the numbers are a little bit smaller. And when I look at them, I say, ooh, they're both even numbers. So that means it's a pretty good chance I'm only going to have to divide once, maybe twice at the most, in order to simplify this. But I'll go ahead and show you how it looks using the GCF method as well. Because again, since the numbers are smaller, you could also argue the GCF method is better because you won't have to list too many factors. So if we look at our factors of 6, we have 1 times 6, 2 times 3, and that's it. Those are the only numbers that multiply together to equal 6. Now when we look at 10, we have 1 times 10 and 2 times 5. That's it. Those are the only factors. Those are the only numbers that multiply together to equal 10. So when we look at this, I notice that they have a 1 in common and a 2 in common. Well, 2 is greater, so that means our GCF is 2. So I know and I am confident in saying that if I divide this fraction 6/10 by the greatest common factor of 2, I will have simplified this in lowest terms. 6 divided by 2 is 3. 10 divided by 2 is 5, giving us our simplified fraction of 3/5. All right, let's look at this one. So I'm going to do this one using repeated division. I might kind of go back and forth. You guys can get an even number of examples between the two. So if I look at 9/27, I'm going to say, okay, I want to see what is in common. What can I divide both 9 and 27 by? The first thing that comes to mind for me is I can divide them both by 3 because I know that 9 is divisible by 3 and 27 is divisible by 3. So if I do that, 9 divided by 3 is 3. 27 divided by 3 is 9. Like I said, with repeated division, after you do that first division, you got to look carefully and say, are we done? Or can we divide by something else? Is there another common factor? Well, I have both 3 and 9. The only factors of 3 are 1 and 3. And well, 9 is divisible by 3, as we just proved. So that means there is another factor. I need to divide by 3 again to fully simplify this. So 3 divided by 3 is 1. 9 divided by 3 is 3. And now we have fully simplified our fraction here. If you had chose to go the GCF route, I am kind of changing my mind here. I'll go ahead and show you that real quick, how that would have worked, and you would have gotten the same answer. So if we come over to the right here, if I list my factors of 9, we have 1 and 9, and 3 and 3. Then if we list our factors of 27, 1 and 27, 2 doesn't work because it's not an even number, but 3 works, 3 and 9, 4 doesn't work, 5 doesn't work, does 6 work? Nope, 6 doesn't work. That's it, actually. Those are my only factors. Well, when we look at our common factors here, we can see that they have a 1 in common, they have a 3 in common, and they have a 9 in common. So our greatest common factor is 9. So if we take our fraction, 9 over 27, and divide by our GCF of 9, 9 divided by 9 is 1. 27 divided by 9 is 3. Look at that, the exact same answer. So that's why it doesn't really matter which method you use. It's whatever you're comfortable with, because as long as you use either method correctly, you'll be able to simplify and get your fraction in lowest terms. All right, we'll do 2 more examples together real quick here to round us out. So I'm getting higher up into the SMART scores, which means the numbers are maybe getting a little bit harder to do in your head. You might have to list out more of the factors in order to do them. So I see 33 over 72. This is one I'm not super familiar with, and the first thing I notice is that both of the numbers aren't even, so I can't divide by 2 to make them smaller and see if it's something that's more manageable in my head to do. So I am going to choose the GCF method for this one. So if I look at 33, I know I have 1 times 33. 2 is not going to work because it's not an even number. Then I have 3 and 11, because 3 times 11 is 33. 4 doesn't work, 5 doesn't work. And if you're not sure whether the numbers work or not, remember you can use a calculator, because when you're finding your factors, you're wanting to know the 2 numbers that multiply together to equal 33. Well, you can use your calculator to think backwards and say, okay, well, what? Because if I want to know what times what is equal to 33, we can do division. So if I take 33 and divide it by 3 in my calculator, I get 11. So that tells me that 3 times 11 is 33. That's a factor there. And then if I'm not sure if 4 works, I can take 33 and divide it by 4 and see that I get a decimal answer. When we're listing our factors, we only want whole numbers. So decimals aren't allowed, which means 4 is not a factor because we get a decimal. We don't get a whole number. And if I were to keep doing that in my calculator, I would see that if I take 33 divided by 5, I get a decimal. Divided by 6 is a decimal. 7 is a decimal. Divided by 8 is a decimal. Divided by 9 is a decimal. Divided by 10 is a decimal. And then finally, when I divide it by 11, I get 3 again. But I know that I'm done because I've worked my way back around. So those are clearly the only factors of 33. So now I'm going to list my factors of 72. We have 1 and 72. Now it is an even number, so I know it's divisible by 2, so I'm going to start there. 72 divided by 2 is 36, so 2 and 36 work. I'm not sure if 3 works or not, so I'll use my calculator and say 72 divided by 3. Looky there, it's a whole number, it works. So we have 3 and 24. And then does 4 work? Yep, 4 and 18. I know 5 doesn't work because in order for 5 to be, a number that we can divide by, it has to end in a 5 or a 0. 6 works. We have 6 times 12. 7 doesn't work. 72 divided by 7 is a decimal, but 8 works. We get 8 times 9, and obviously there's no whole numbers between there, so that signifies to me that I'm done. I've listed all my factors of 72. All right, let's find that GCF. Let's find that greatest that they have in common. They obviously have a 1 in common. And then I see that they have a 3 in common. Is there an 11 anywhere? Nope. So that means our GCF would be 3. So I can simplify this fraction by dividing the numerator and denominator by 3. So 33 divided by 3 would be 11. 72 divided by 3 would be 24. And even though the numbers are a little bit larger, I know that I picked the GCF. I didn't miss any factors. I am confident that that is my simplified fraction. And it is okay that it's a slightly, make sure you're careful to type the numbers in correctly, that it's a slightly larger version. That's just as simple as it can get. All right, let's do our last one here. So once again, we have numbers that are a little larger. This time I'm going to use repeated division. I'm like, you know what? Yes, these are numbers that I'm not super familiar with, but because I'm not familiar with, I think it would be harder to try to list all the factors. So I'm just gonna go through and do some testing, see what's in common, what I can divide by, and use the repeated division method. So first thing I notice is when I look at 61 and 93, I always look to see if they're even numbers, because if they're even numbers, I know I can divide by 2, and they're not. They both happen to be odd numbers. So the next thing I'm going to check is, hey, are they divisible by 3? I'm just kind of going to go in order. 2 doesn't work. Let's try 3. So I'll use my calculator and say 61 divided by 3. I get a decimal, so that doesn't work. Let's try 4. 61's not divisible by 4. That doesn't work. By 5, no. 6, no. Oh my goodness. By 7, no. By 8, no. By 9, no. 10 doesn't work. Oh my goodness. I was trying to be easier. Maybe not. 11 doesn't work. About 12. No. 13, no. 14 doesn't work. What about 15? No. 16? I wonder if this is a prime number, maybe. Maybe there's no other factors. Oh, if it happens to be prime, we're going to see here, then that means you can't simplify it all because the only numbers, unless 63 is also divisible by 61. If I take 93 and divide that by 61, I get a decimal, not going to work. Let's see if this has already been written in lowest terms or if I accidentally missed a factor that I can divide 61 by. Look at that, it's correct. So I'm really glad we did that one together because that can happen. If you have a prime number and your other number, whether it's the numerator or denominator, is not divisible by that, it may already be in lowest form, which is what we had there. So there you go. All right, I hope this video helped. Hopefully me doing the 2 different methods didn't confuse you. Hopefully it kind of opened your eyes to see that you can do either one, and whichever one you gravitate towards, you can use. But if you would like to see some other examples or just see how exactly IXL does it, you totally can. Right here is a video that you can watch. And then as always, remember, if you get a problem wrong, actually, I'm going to get this problem wrong real quick. I know it can't be 1/2. I'm just going to put that in. It will not only tell you what the correct answer is, but if you scroll down, you can see in both word form and then in example form how to solve it correctly. So it's a great way for you to read through, compare, see what you did wrong, and then hopefully learn from that mistake. All right, good luck. It is your turn to work on this assignment. If you have any questions, please reach out. But you got this. Bye.